Morning, dear primary 6 students of St. Joseph's International School. Today we continue our series of videos explaining and discussing uh, primary 6 science curriculum. And if you remember, in the last video we started to talk about a very important concept, which is heat transfer. In this video, we continue talking about the same thing and more information about it. So, let's begin. First, to recap our understanding, let's try and answer these questions. So put true or false after looking at this picture. So when making a handle of a cooking pot, it should be made of a metal to conduct heat. The keyword here is making a handle. Is that true or false? Well, that's false, because you want it to insulate heat, not conduct it. Handle of cooking pot is made of wood or plastic to provide safety to users. Well, that's correct, so that's true. Good. So we know that we have good conductors and bad conductors or thermal insulators. So let's try and take a look at this experiment here. We have a pan that has a handle of 18 centimeters. And it's made of plastic. And we heat the pan for 10 minutes. And now we are using a thermometer to measure the temperatures at different spots along the handle of the pan. So when we measure it near the pan, it's 54 degrees, which is hot. When we measure it in the middle of the pan, it's 24 degrees. And when we measure it at the end of the handle, it's 23 degrees. This means that plastic reduces the temperature of the heat coming out of the fire and the pan, and this way it protects you when you hold it. So plastic is a good example. But let's imagine we have another pan that has a handle that's also made of plastic, but it's 36 centimeters long. And it's also heated for 10 minutes. Now, when you measure the temperature near the pan, it's 54, same as the 18 centimeters one. But when you measure it in the middle, it's 23 degrees. But when you measure it at the end of the handle, it's 22. Well, it made it less, so it's better to hold it, but the taller the handle, the longer it is, the more it costs, and also it's harder to hold the pan this way. Now let's take a look at another pan that has a handle that's 36 centimeters, but this time it's made of wood, and it's also heated for 10 minutes. When you measure near the pan, it's 60 degrees. But when you measure in the middle of the handle, it's 25 degrees, and at the end of the handle is 24 degrees. So this means that plastic is better than wood to protect your hands. And also this means that wood warms up faster than plastic. Good. Let's try and answer these questions. It's better to use a handle made of plastic or iron than a wooden handle. Plastic, of course. An iron handle is the worst anyway. Well, the long or short plastic handle is the best choice for handles. So the best choice, of course, is long because it lowers the temperature more and more. Now, let's talk about one of the very important concepts in science and in physics, which is the conservation of mass. Conservation means saving or protection. Well, what's meant by the law of conservation of mass? The mass of a substance doesn't change when this substance changes from one state to another. What we mean by that is, let's have 100 grams of ice cubes. When you melt them, there are 100 grams of water, liquid water, right? So the mass doesn't change when you change the state of an object. Because a very important thing in physics and in science is that matter is neither destroyed nor created, but it only changes from one state to another. Good. Another example is you have a cup of juice and it's liquid, of course, and you put it in the freezer and it has the same mass even if it's solid now. Good. Sometimes a few grams are lost. Why? Because they evaporate. They don't disappear, but they evaporate. So let's try and answer these questions. If you melt a chocolate bar with a mass 150 grams, its mass after melting may equal 149, 97, or 180. So definitely not 180, because it cannot increase. But it decreases slightly because maybe it had 1 gram of water that evaporated. Well, but it cannot be 97 either, because that's too much. Second question, if you freeze a cup of 200 grams of water, its mass after freezing is less than, equal to, or more than 200 grams. Of course, it's equal to. Good. Moving on to the next lesson. Let's try and answer these questions first. Mazen has kinetic energy more than Amir. Is that true or false? Remember from primary 4. Of course, that's false. Sorry. So yeah, that's false. Why? Because he is not moving. But Amir is sliding down the slide. Second question. Mazen has a bigger amount of potential energy than Amir. That's true, because the higher the body, the more potential energy it has. So this way we are learning about how objects can convert the kind of energy they have. So here Mazen has more potential energy and it's converted into kinetic energy as he goes down the slide. Same thing happens to the marble. But also as the kinetic energy increases, we learn that the thermal energy increases due to friction, right? So the marble at the top has less kinetic energy and obviously less thermal energy than the marble at the bottom. So let's try and answer these questions. Energy doesn't change from one form to another. That's definitely wrong. Energy always changes from one form, from one type to another. Second, when friction happens, some of the kinetic energy changes into thermal energy. That's true. Third, when an object is placed at a high place, it has potential energy, and that's also true. Last lesson is going to be talking about some new materials. Well, one very important thing that engineers do is that they create new materials with new properties. For example, when we make clothes, we want it to be soft materials. When we make a bicycle or a car, we can't use cloth. We need a hard material. So, for example, here, engineers and scientists develop a very good kind of cloth which is called the smart cloth, and it has three important properties. First, it controls your body temperature, so it keeps you warm when it's cold and it keeps you cool when it's hot. Second, it lights up in the dark, so when you're riding a bicycle at night and you need it to light up so people in cars and other bicycles can see you. And finally, they keep themselves clean. So how do we make new materials? By a very easy way, by mixing materials together. So for example, we have steel. Steel is a mixture of iron and other elements, and it lasts longer and it's much stronger than normal iron. Another example of that is concrete. Concrete is a mixture of rock, sand, and water. And at first, it's a liquid until it becomes solid and hard, until it becomes dry, and this makes it solid and hard. And it's used as the base of buildings and bridges because it's very strong. Another way we can make new materials is by changing something inside of their chemistry and its components. We can do that by, for example, we have petroleum, and it's liquid and it burns easily. Another example is plastic, which is a tough solid and it often resists burning. Very good. Another thing that scientists made is shrink wrap, which is created when we add heat to plastic to make it shrink. Shrink wrap is used to wrap bottles together around each other. Very good. We remember glass when we talked about glass blowing as well, and glass is made from a mixture of sand with small amount of other materials such as limestone and soda ash, which is sodium carbonate. And this mixture is heated in a very hot furnace until it melts and it changes into glass. Then the glass becomes hard when it cools. Good. Finally, let's try and answer these questions. In making all materials, we should add heat. That's not true, because it's not true all the time. We don't need heat all the time. Second, steel is made of rock and water. That's false. Steel is made of iron and other elements. Finally, when chemical change happens, the properties of the new materials are the same properties of the original materials. That's also false, because the properties change and the chemical due to the changes in the chemical structure of the material. This has been all for our science curriculum for primary 6 in the first term. Hopefully you understood everything and this has helped you study. And as usual, if you have any questions, you can always ask your teacher or you can always ask through the website. Thank you so much and good luck with your exam.